Hi all, this is Harini. Welcome back to our YouTube channel Code with Harini. Today we are going to solve LeetCode challenge day 10 reschedule meetings for maximum free time. It's a slighter, harder version of the question which we solved yesterday. So basically, if you look into the question, they'll be giving the same event time, denoting the duration of the event, and given two integers start time and end time. Two integer arrays. Okay, so if you just take a look, the event time is from 0, the event happens for 0 to 5, and what all the events got scheduled will be declared in the start and end time. So the first event starts at 1 and ends at 2, second event starts at 3 and ends at 5. So what they are telling, so they represents the start and end types of n overlapping meetings that occur during the event time t0 to event time. So we can reschedule at most one meeting by moving its start and end by moving this meeting while maintaining the same duration. We can move any one of this meeting for 1 comma 2 1 to 2 to 2 to 3, so that the overall event free period will be maximum. So that's what we have to return, the maximum amount of free time possible after rearranging the meeting. So in this they have told to rearrange the meetings, but they haven't mentioned like we have to maintain the same order. Event 1, event 2 should be at the, even after rearranging also it should be the same. But yesterday's question it was the same. So we have to rearrange first meeting at the first position, at first meeting should be at the first. So you can move the meetings between the free times to maximize the free time, but not shifting to some other free time which is available between any other two not adjacent event. So let's take a look at this example. Here we'll be moving the 7 to 8 to 8 to 9 or 7 to 8 to 1 comma 2, so that we'll have the maximum free time. So here if you take a look, so we are moving this 3 comma 4 to 8 to 9, which is non-adjacent free time, right? So generally yesterday's question was you can move k events to its adjacent free times, but here 3 comma 4 is going to shift into 8 to 9. So which means this free time is non-adjacent to 3 comma 4. So that is the only difference that we are going to see in this. So in this, if you just look into anything, we have got two cases. One, you can move it to its adjacent, or you can move to the left free slot available or right free slot available, so that you can have whole 1 comma 7 as your whole free time. So this is what, so we have to consider here two cases. So yeah, that's it. Let's take a look at the example. So I have already written here one example which is the same which we have discussed now. So this is 0 comma 1 3 comma 4 7 comma 8 9 comma 10. So here first case case 1 would be we could have moved this event to here or here, but if you would have moved here to here, so what will be 7 minus 2 is 5. 5 only we would have got. So but if we move to here, the whole right left whatever the free times we are getting is full. We will be having the full free time, right? That 7 minus 1 equals to 6. So because basically we are moving this to here. So in case 1, either another example, if we would have taken 0 1 5 6 7 8 9 10 9 10 7 8 0 to 1. In this case, what our solution is, we are moving this to here. That's it. So we have to consider two cases here. So case 1 should be move the available move the time period to available free slot which is non-adjacent. So this will give you always the maximum. If not, we should consider the case move to adjacent free slot to either one side. So this is the thing. So first, whenever you are moving any time period that is exists that can fit into non-adjacent time slot, so obviously our free period will be maximum, right? If not, we have to move to any one of the any one corner side of the free time. Yeah, by this we can solve the question. I hope the question explanation. Yesterday's question is K. So we will be keep on bulking up the K and their left and right. If you haven't watched the yesterday's video, I highly recommend you guys to go and watch the video so that you can familiar with at least one case two. Now just we will be just looking into the case one in this. Still I'll be explaining, but you guys will be have more familiarity how this case one works at least. Yesterday we would have looked into till k. So now for case two we'll be considering only k equals to 1. That's it. Only difference from yesterday's solution for and today's case two will be k equals to 1. There it will be k can vary at any value. So I hope the question explanation makes sense. Now let's look into the solution. So this is the solution. So what I'm doing is first we should know what are the free number of available free slots available for each the each time period. If you got to know, then it is easy to assume whether it will be fit into previous or it will be fit into any of the previous non-adjacent time slot that we will be checking. So that we need to know what are the time slots that is available previous. Correct. How we will be calculating? So whenever you are traversing from the event, if we are subtracting, for example, let's take I'm here at this position. If you are subtracting the start time of I minus end time of I minus 1, you will get the free time. So that you add, okay, that you add it to the total free time available. So the same, so like this if we go, we can what we can traverse what are the free times available from the left. So also we should take the maximum. So if you keep on having this maximum value, so whatever the time period comes, if we just know, yeah, that because we have to fit change only one na, so you don't need to count all that. You can just have the maximum one that is available before this time period. So that's so the same way we'll be traversing from left to right to have what are the previous available free time slots on the left side. The same way we should also know check some whether something is available at right as well, so that I can move this to here. So that how will you calculate from right to left? That we will be calculating from right to left. So that's what we'll be going to do. So instead of running through the loops order of 2n, we know starting the loop from, let's assume you are traversing from, you are going to calculate total available free slot from left. So how will you calculate? So you are traversing through the loop for I in range 1 comma n. So for I in range 1 comma n, what will be from left to right? If your I equals to 0, okay, for left to right, if our I equals to 0, what should be from right to left? So right, let it be here. So what will be our way? Right to left, what will be our, so it should be now if you are taking it as a I, that should be n minus I, right? So n minus I minus 1. So for example, from left to right we have 0, so right to left should be 4 minus 1. So 4 minus 0 minus 1 will give us 3, which is this. So right loop should start from 3 till 0. Left loop should start from 0 till 3. Okay, that's what. So basically if you're putting n minus I minus 1, so when I equals to 1, let's assume 4 minus 1 minus 1, which will give you 2. So 3, next to 2, next to 1, next to 0. So this will go 0, 1, 2, 3. So that's why. So with one loop itself, we can traverse both left to right and right to left. So that's what I was trying to say here. So I hope that makes sense why we are using single loop. Now let's look into the solution. Now to calculate from left to right, I have a variable total free time available from left. To calculate right to left, we have total free time available from right. Now so now before now let's assume you are taking this, so and you are trying to place this either to left, or we are checking whether the free time slot available. Okay, so what will we be doing? What is the time period for this? How will you find out this time period? So start time of, sorry, end time of I minus start time of I. So which means 1 minus 0 will give you 1. The same for 4 minus 3 will give you 1. 8 minus 7 will give you 1. The same 10 minus 9. So even whatever it is, if for any, for this traversal, if end time of I minus start time of I will give us that time period, and we will be checking is there any free slot available before or after. By using this variable total free time that will have our maximum available, right? So yeah, by then if so actually if you see the time period is less than the total time period available from the left, which means this, then obviously we won't have it here. We will be moving that to before, so that we will have the more free time. That's what here. So if you, maybe I can move it slight bit here now. Okay, so that's what we are checking. If it is less than or equals to the total available free time from the left, then you are setting that okay, free time available for this particular index, and we are setting that. Okay, so then how we'll be calculating the free time available from left. So obviously we know for this, if I equals to 0, there is no previous time period exists. So you will be giving how we will be calculating the free time. Let's take this as first example. So start time of current I. So let's take I is here, start time of I, and the previous end time will give us the free time. So that among that, whatever the maximum that we will be taking. So that's what we have mentioned here. Total free time available from max of total free time available from less start time of I minus end time of I minus 1. Why we are having this if or else condition? So if I equals to 0, for which means previous there is no time period exist. correct? So the left will be 0 and the right will be the start time of that I. So that's what, if I equals to 0, use as 0, else end time of I minus 1. If I is here, then this is the end time of minus 1. So 3 minus 1 will give us 2. That is the free time. So this is how it. So the for the right, now this is for left to right case, right? So now when it is from right to left, so what will, this is Ri, okay? Start time will be, so the same here also we'll be checking whether end time of n minus I minus 1, end time minus start time of n minus I minus 1 is less than or equals to. So something that we can put it in the right. That's what we are checking. Total free time available from right as less. Okay. Now we have checked the left. Now we are checking right. For each value that is traversing from right to left, from left to right, we are checking. Okay, any free, because that's what we would have calculated. Okay, free time, when you are traversing from left to right, we would have calculated all the free times that is available on the left. So when you are traversing from right to left, you would have calculated all the free times available on the right? So that's why we'll be checking every time if the index, if for particular I traverse from left to right, so you are checking whether that particular end time minus start time uh, of that particular time period can be fit into any of the left free time available. The same, any of the right free time available. That's what we are. Oh, I hope this makes sense why we are putting this. In let it, so the same we are checking, and if, yeah, if that is less than or equal to total free time available from right, we are updating the free time of n minus I minus 1 equals to true. So then how we'll be updating the maximum free time available? So the same. So we should subtract the start time of n minus I minus, sorry, n minus I, this start time, and the next end time. So this is the end time, right? For this event, okay, what will be the start time? Start time will be the event time, right? So that's what, if I equals to 0 for the right index, start time will be the event time and the end time will be n minus I minus 1. Okay, so for example, I goes here. Okay, now the start time for how will you calculate this? So that will be n minus I. So the previous start time and the current end time. So that's how it will be. So previous start time and current end time will give you the free space available after any period. I hope this makes sense why we are giving I equals to 0. We are taking event time because right is at last. So we have to calculate what is something free slot available on the right? So at the last, what will be our for the last time period, even time will be the last, right? So that's what. So when n minus, why we are doing n minus I is, so this index will be n minus I minus 1. So this start time minus n minus I minus 1 end time will give you the free time. I hope this is also makes clear. why we are doing that. Then once you have calculated all the free times, and you will be updating the free time available. Now these all, now tell now what we have calculated, what all the previous time slots, previous uh, available time slots, and whether this particular time period can fit into previous or later. That's what from we would have updated that. Now we will be looking into these two cases and update the result. Case one is move the time period to available free slot which is non-adjacent. That so now we are traversing for each left and right. So now for take any now you take any, for example let me take this 3 comma 4. Okay, 3 comma 4, this is what yesterday's, so what will be the left for this 3 comma 4, which is 1. Now we will be counting the left and right for any particular index, and we will be checking whether can we move this to here to get the maximum, or if this for this free time available will be moving to the free time. That's what we are going to do. For this, now what we have to do, we have to find out the left period and the right period. So what will be getting here, we will be getting the left equals to 1 and right equals to 7. Okay, but when you can see the free, this for this free time slot will be available from the right. So that's what we are checking. We would have updated the free time available here. So now the free time available came. So now what we can do, we can just subtract the 7 minus 1 equals to 6, because we are moving this to here, right? So you can just subtract 7 minus 1. So in some case, let's assume we don't have the space as well. Then what we should have done, we should have moved this period to any one of the corners. So what we just need to subtract right minus left minus start time, end time of I minus this period we have to subtract as, in addition to subtracting right minus left, we have to subtract this as well. I hope this makes clear to you guys how the solution works. So basically we are not doing anything, we are just again I'm just repeating this thing. What we are doing, we have just two variables, total free time available from left, which is calculating from left to right what all the slots available for any particular index on their left. The same from right to left, what all the particular index that is available on their right. I have clearly explained why we are having this I equals to 0, how come these conditions and all works by showing with example. So when to any particular index, if you start, uh, you would have calculated already free time available from the left. So that if you do the start of I, sorry, end of I minus start of I, which is less than the total free time available on the left, what you can do, obviously you can set okay, some free time available for this particular index, there is some free time available, so you can set it to true. So the same. So then we are updating the total free time available from the left based on the start time of I minus end time of I minus 1. That's what we have written here. The same for the right. So once we have updated all the total free time available from right and left, now we know what is available from right and left. So obviously if for any time free time exists between any free time exists for any adjacent free time exists for any particular time period, if we remove that time period, obviously the free period will get merged. So what our resultant answer will be a maximum rather than moving that to the nearest adjacent corners, right? So that's why we are doing, if free time is available, obviously whatever we are getting will be the maximum. So if not, we will be subtracting by the time period, which means we are moving that, we are merging still, but we are moving it to the any corner, and we are having the free time together. That's it. I hope this makes clear to you guys. Maybe I can add a free time. So free time will be 0, 1, 2, 0, 1, 2, 3. These are the free times. So now let's take a example. So I will be ranging from 0 to 3. Okay. Now let's take I equals to 0. So in time of I is 1 minus 0, which is 1. The total free time available, let's have total free time available at left, total free time available at right. Both are currently 0, right? So 1 minus 0 is less than or equals to total from so no, we will not update the false value because it is false, because we can't, because we don't have anything before, right? So obviously it will be false. So now how will you update the free time? So free time is nothing but so now we will be updating the total free time by start time of I, which is this, start time of I, which is 0, minus before that there was no index exist, so that's why if I equals to that's why what we have chosen, if I equals to 0, you just take 0, not n minus I minus 1. So 0 minus 0 is still 0, so free time won't be updated. So next let's go to the index I equals to 1, which will be here. So 4 minus 3 will give you 1. Okay. Is there any free time available still on the left? Yes, it is available. But that we will be calculating now only, right? Because for the next index one, so first whatever the free time we are calculating here, that is not for the adjacent periods, that is for non-adjacent periods. So yeah, because this, if you have to move to here, we would have used the case 2, which means you calculate I plus 1 start time, I minus 1 end time, and whatever I plus 1 start time, I minus 1 end time, minus 7 minus 1 6 minus our time period will give you already. So there is no need of storing it in the other free time. Free time slot available is basically for non-adjacent slots basically. Okay, that let's keep it in a mind. So the same, I forgot to put it the same for the right. So the for I equals to 0 itself, we will have right traversal, right? So for that right traversal, if you see, so n time n minus I minus 1 is this, correct? So 9 minus 10 will give us 1. So we also checking, is there anything available on the right? Even time itself already 10 minus n time of n minus I, sorry, yeah, which is the current index, and the next start time. okay, which is n minus I. So 10 minus 10 is equal to 0. So this is also 0. Now the I equals to 1 comes here, okay, which means 4 minus 3, right? So if you check, we are going to check the end time minus start time and the available free time exists. So 4 minus 3 equals to 1. Available free time on the left is 0. Now we are going to update the available free time on the left, which means start time of the I minus end time of I minus 1. So 3 minus 1, which is 2. That will be updating. Now we found one time slot. Okay. Now we'll be going for the right case. So now the right for I equals to 1, it will come here, right? So which means 8 minus 7. So 8 minus 7 equals to 1, but we don't have any non-adjacent time slots available. So what will be our start time of n minus I, which is this, end time of n minus I minus 1. So 9 minus 8 equals to 1 we are getting. So that we will be updating to 1. Okay. Now I will traverse to 2. Now I went here. Okay. Now I went here. Now what are the same? 7 minus 8 again 8 minus 7 equals to 1. This free slot will be getting updated to 4 minus 7, which is 3 at the left, which is 3. Again it does for this from left to right traversal, I will be coming here. So now right pointer is here, left point. So now it is going here. Now 4 minus 3 equals to 1. So for this also, now if you see, 7 minus 4 will be 3. Okay, we would have updated free slot available for 2. For this also we would have updated to 2. For this also we would have updated. So for now I equals to 2 we have updated. For I equals to 1 also we got the free slot, right? Yes. So yeah. Now when I equals to 3, when I comes here, L goes here, there is no free slot. For this we have the free slot on the right. For this we have free slot on the left. So obviously those free slots also will have got updated to true. But maximum is 3. Here 3, so here 3 minus 1 again comes 2, but already maximum is 3. Here 10, 9 minus 8 will be giving you 1. So yeah, I hope how this comes. Now the free slot, all this got updated. Now after this we know the free slots, right? Again we will be traversing. This is for non-adjacent slots. So now we'll be traversing again from I equals to 0 to 3. Let's take every and we'll be checking whether free slot is for 0, right? For 0 as well, at the end we got the right free slot, right? So everything would have updated to true. So now if you see, because for this we have slots available at the right? So now all this we have free slots available either on the left, either on the right. So this means either on the non-adjacent right or non-adjacent left. Okay. Now we are traversing again to 0 to 3. Now we will be checking if this is true. Removing this makes the free time more. What will be our left for any period? For if I equals to 0, the left will be 0. So that's what we are checking. For I equals to n minus 1, right will be even time. So that's what we have added. Else, what will be for this particular index? How we will be calculating I minus 1 end time, I plus 1 start time. So with so let's if you take this, you can clearly understand. So I plus 1 start time, I minus 1 end time. Okay, by that we will be getting the left and right. So let me take the for this example. What will be my left is 7, right equals to 1. I just took this example. I'm just traversing for this alone. So 1 7. But if you see my I is 1. So now what I will be checking the case 1 is we will be checking non-adjacent slot is available, which will be always maximum, because we will be removing this time period to somewhere. So this time slot whole right minus left will be the maximum. So that's what we are doing. So right minus left. If free time available is there, then you should do right minus left. If not, there is no free time available on the part. For example, let's take this. If we have like this, so do we have any 3 time slots available before or after? No, right? In that case, what we would have done, we would have gone to else condition, maximum 7 minus 1 minus start time of 6 minus 3, which will be minus 3 minus 1. So which will be 3 will be our maximum result in this case. So yeah, we would have moved this 3 to any of the adjacent free slots, and we would have the free 4 minus 7, 3 will be our result. So I hope this clearly explains how this case 1 and case 2 works. So here, if you look into the time complexity is order of 2n, and space complexity is order of n, where we are storing this free time available. So let's take a look how we can avoid the space complexity order of n. So if you look into this for loop, we are updating this max free rate in 3 conditions when this free time of available is true. So wherever you are updating the free time of available, why we can straight away update, right, max free time, so that you don't need to store the free time available of I. Also another case where there is no non-adjacent there is no non-adjacent free slot exists, we will be moving it to a adjacent free slot to either one side. So in that case, so that we can update, so that we are updating based on the left and right. So what we are going to do is, so at any particular period we are taking and we are finding whatever the non-adjacent slots available, and we are going to find what is the free time period if we are moving it to the adjacent slot, all this. So we are just removing the free time available from here and here and update this to max free time. So let's take a look at that. So now if you see, wherever we are going to update the free time available, I just updated to max free time, right one minus left one. Here the same, if in time of I minus 1 minus start minus 1 less than or equals to total free time available on the right, then obviously what we are doing, we are updating the max free time, right to minus left. So why this right to minus left to and left right one minus left one? Because we will be traversing from first, when you are going from this index to this, we won't know something we are calculating on the right. Correct, obviously. So left for any particular index, when you are going here for this left end time and the start, sorry, this will be your I minus 1, I plus 1 will be our end index. Correct. So that but when the from right to left when you are traversing, I will be at different place. When left to right when you are traversing, I will be at different place. So that's why we are doing I left one, left right one for when you are traversing from right to left. So left equals to 0 if I equals to 0. Obviously every we know left equals to 0. All else what we will be doing, end time of, if I is here, end time of I minus 1 and start time of I plus 1. So see the same. So when you are traversing from right to left, to calculate for any period between any of the elements, what we will be doing, so end time will be for end time will be, so right will be end time of, sorry, n minus I, sorry, my bad. This will be the start time, right? Sorry. For I, let's assume I is here. We are traversing from right to left to get this period. Okay, initially the when I here for here for this case, this is from left to right. This is from right to left case. So right to left case we have different left and right, obviously, right? For the same left and right we have different right and left. So 9 minus 4, to get 9 minus 4 equals to 5, and we will be checking any other previous slots available that we will be updating. So this is the left and right, basically left to and right to we need. Okay, so from that we will be checking 7 minus 8 has any non-adjacent slot. No. So if exist, for example, when I to right to left comes here, this I comes here, obviously we know one non-adjacent slot exists here, so that will have become true and that will update our maximum free time to 7 minus 1 equals to 6. So like this we can avoid additional total free time available. I hope you understood here. So basically what we did, wherever free time available of I occurs, we moved that condition right minus left to wherever we have added the free time available, and this else condition we have straight away added it here, max free time of right minus left minus end time minus start time of any particular ith index, so that this will result in moving to the any nearest free slots. Yeah, and we have updated instead of maximum available free available time slots of I to max free time condition straight away in both the cases. By that we have avoided order of n space complexity. Now time complexity will be order of n, space complexity will be order of 1. I hope this makes sense. I have even attached the code, so there is no need to explain specifically in the LeetCode solution. Yeah, I'll be attaching the solutions via GitHub link. You can go and check it out. If you have any further questions, please do leave a comment. Yeah, I'll be happy if you guys solved and understood this question. If you like my explanation, do like, follow, and subscribe, and click the bell icon so that you will be always notified when I post the new videos. Yeah, thanks for watching. Thanks for your support.